So now, the instantaneous rate of change of the velocity function is known as the acceleration function. So again, you have your formal definition of a derivative, but this time we're using velocity, if you notice, okay? So basically you're finding the derivative velocity, which is basically the second derivative of your position function. Now acceleration, if it's greater than 0, then the velocity of the object is increasing, meaning we're speeding up or getting faster. If the acceleration is less than 0, that means the velocity of the object is decreasing, which means it's slowing down. Lastly, if it's equal to 0, that means the velocity is constant, which means we're not speeding up or slowing down. Okay? Now we look at the next example. It says for the displacement function in the last example, we found that velocity was that function. So I'm using the same type of situation, we're just going to find new information about it. It says find the average acceleration of the particle from 1 second to 4 seconds. Average acceleration. Okay, there's a difference between average and instantaneous. Remember, average acceleration is just old school slow. Okay, so that means I need to do y2 minus y1 over x2 minus x1. But in this case, I'm going to use my velocity function to basically represent my y. And then, of course, my x's are just my normal time. Okay, so the change in my velocity over the change in my time. So when I plug this in, I'm going to get an average acceleration of negative 12 meters per second, okay? And actually, you could have figured that out too. You can always pause the video and try to work it out before I actually work it out, okay? Even if I don't say it, you can still do it. Now to find the instantaneous acceleration, well remember, instantaneous means derivative. So I'm going to take the derivative of my velocity function, and then I'm going to figure out what is instantaneous acceleration when t equals 3, okay? So the derivative of my velocity function is going to be 12t minus 42. So when I actually plug in 3, I'm going to get an instantaneous acceleration of negative 6 meters per second. Okay? Now, you should note that a negative acceleration doesn't mean the object in motion is slowing down. It just means that the velocity is decreasing. Okay? So, again, the negative 6 meters per second means the velocity is decreasing 6 meters per second at 3 seconds. Okay? So again, just a negative acceleration does not mean the object in motion is slowing down. It just means the velocity is decreasing. Why? Because velocity and speed are very different. Okay? Speed is the absolute value of velocity. Velocity tells you how fast in the direction, where speed only tells you just how fast a particular particle is moving. So to determine if the object is speeding up or slowing down, you basically are going to compare the signs of velocity and acceleration. Okay? When velocity and acceleration have the same sign, the object in motion is speeding up. And when velocity and acceleration have different signs, that means the object is slowing down. So now we're not just going to be looking at velocity or just acceleration. We've got to look at both of them together to try to figure out if the object is speeding up or slowing down. So we're going to take a look at this last example here to figure out some things. It's the same situation. We have our displacement, we have our velocity, we have our acceleration functions. Now it says find the speed of the particle at t equals 3 seconds and determine whether the particle is speeding up or slowing down when t equals 3. Okay? Well, the first thing we need to do is we need to figure out, okay, what is our velocity at 3 seconds, okay? So all we do is we take our velocity function and plug in 3, and we find out that our velocity at 3 seconds is negative 12 meters per second. Okay? Now speed, like the last slide said, it is the absolute value of velocity. So the absolute value of negative 12 is positive 12. So our speed is 12 meters per second. Okay? Our acceleration at 3 seconds, you gotta find this out too, was what we found out earlier, which was negative 6 meters per second. Okay? So the particle is speeding up at t equals 3 seconds since velocity is less than 0 and acceleration is less than 0, okay? Look at their signs right here. At 3 seconds, they're both negative, okay? So if you remember from the previous slide, when they have the same sign, the object is speeding up, okay? So we know the particle at t equals 3 seconds is speeding up. And again, we know this again because the signs are the same. Now, part B says during 0 to 10 seconds, find the intervals when the particle is speeding up and when it's slowing down. Okay? Well, we have to take a whole bunch of things that we've already done within these last couple of slides. All right? We know that the signs for velocity, we figured that out already because I can't remember which part it was, but remember we did the motion diagram? Well, the motion diagram basically told us when velocity was positive and when it wasn't. So we have 0 to 5. You remember that from the motion diagram? Okay? Or not the motion diagram, it was right here, part G, where we were trying to figure out if we move left or right. Okay, so that was the motion diagram. I'm sorry. It was right there. Now I'm only concerned up into 10 because that's my interval I'm looking at. Okay? And remember we found that it was positive between 0 and 2, negative between 2 and 5, and then positive after 5. Now our signs of A, okay? When we look at our acceleration function, okay? We still have 0, and we still have 10. Now, we're not going to look, just pick a random number in between that interval. We actually are going to have another point, which is 3 point. Now, 3.5, think about it. Where would I get 3.5 from? Well, this represents, again, the acceleration diagram, okay? And so you have to basically are figuring out, you need a point when acceleration is constant, because if not, that means you basically have acceleration that is when velocity is increasing and then when velocity is decreasing. So to figure out, again, 3.5, all you do is you set your acceleration function equal to 0, and then you can come to find out that at 3.5, your velocity is neither increasing nor decreasing. Okay? So again, you pick some test points here. Okay, so I'm going to pick 1, and then I'm going to pick 4. It doesn't matter what test points you pick as long as they fall in between the main points. And then I'm trying to see, okay, where am I decreasing, where am I increasing? Well, when I plug in 1 into my acceleration function, the number's going to be negative. When I plug in 4, the number's going to be positive. So I'm basically decreasing from 0 to 3.5 and increasing from 3.5 to 10. All right? I'm going to erase this so I can finally write down my final answer for part B, which says to find the intervals when the particle is speeding up and when it's slowing down. Well, remember, when the signs are the same, that means the object is speeding up. And when they're different, it means it's slowing down. Okay? Now, it was good for me that I lined these up because you'll easily be able to see that up into 2 seconds is positive with velocity, but it's negative with acceleration, which means, I'm going to write my final answer over here. From 0 to 2, because the signs are different, I am slowing down. Okay? The particle is slowing down. Now, if I look from 2 until 3.5, I'm negative. Okay? Because again, I'm negative from 0 to 3.5 of my acceleration function, and then from 2 to about 3.5 on my velocity, I'm negative as well. So from 2 to 3.5, my signs are the same, which means I am speeding up. Now from 3.5 to what value am I doing what? Okay, think about it. After 3.5 to 5, I'm negative with velocity, but I'm positive with acceleration. So from 3.5 to 5, I am slowing down because my signs are different. And then lastly, from 5 to 10, I am speeding up because my signs are the same. Okay? And that's exactly how you would write it. Okay? Simple enough. So, try those 2 problems that you guys got in class on Friday. Bring your questions to class on Tuesday, because I don't see you guys on Monday. And you will see all your classes Tuesday, Wednesday, and Thursday of next week. So please make sure you bring this homework done on Tuesday. And if you happen to have any questions over the weekend, let me know. And I'll do my best to help you.